Hello everybody, I hope you guys are doing fine. In this programming series, I am going to cover some of the common mistakes that we do in Python, and it helps us to pay extra attention while writing the code, reading the code, and reviewing others' code. Let's get started. In this particular lesson, we will look at common mistakes we do using lists. So one of the obvious ones is index error. You can see that we are trying to access the fourth element, but it results in this error, especially for beginners. In our day-to-day lives, since we are used to begin the counting from 1, we may start counting like 1, 2, 3, and 4, and we try to access this element which has the value 40, and we get this particular error called as list index out of range. This happens primarily because in computer programming the indexes start from 0, so we should be counting 0, 1, 2, 3. So in order to fix this, we just need to access it like this and then rerun it. There you go. So that's number one. Let us look at another one. There's another interesting example where we remove or modify the list within the loop, and let's see what happens. We have a program which has we have a list which consists of about which has numbers from we have a list which has numbers from 1 to 8, and we're trying to iterate over it, and we're trying to remove a number which happens only if the item is modulo 2 double equal to 0, which means if it is even number. So let us see if it works. Surprisingly, it looks like it works. This is why we sort of assume that this works for all the conditions, and we sort of ignore this particular suggestion or recommendation by Python that removing or modifying the list results in an unexpected behavior. So let us take another example. So I have a list which has number of elements, and all the elements are 3, and we try to iterate over that list, and let's try to remove an item only if that item is equal to 3, which means the outcome of this program should be an empty list when we finish the program. Let's see how it works. You can see the final list. It has not removed all of the numbers, all of the 3 that we wanted. So we ideally wanted just this, an empty list. Now let's see why it happens. It happens because there are 2 things that is involved in this program. One is the indexes, another is values. So let us try to decode this. Let me just remove all of this, and so I have the same program, but in order to reduce our problem set, I have limited number of 3s to just 2 elements. That is, the list consists of 2 3s, and we also enumerate it to understand how the iteration works, and we are trying to print the index. So this is what the enumerate means. That's the line number 3. This print is coming from line number 3 here, and current index at line number 5 during the first iteration is index 0, and we have size 2, and then current item is 3 because we only have 3 in this. So once we remove 3, here. So the size gets updated automatically inside the list. So that is not reflected here at enumerate. So at this level, it is at line number 4, when it tries to get another element, it is not aware. So it tries to get the element, but it doesn't. As I explained, there are two things that is happening here. One is the index and another is value. So when we remove an element at line number 7, there is a re-indexing that happens. So the second tree moves up to the first element and size gets updated, but it does not get updated at this level, which is line number 4 at enumerate level. So it is not aware that the element has moved from second place to the first place, which is index 0, and hence it exits out of the list and we get 1 3 remaining from that list. So we need to be very careful about this particular behavior, that is to modify the list during the iteration, because there are several examples which looks just fine, but when we have complex logic like if conditions on top of these elements, it gets into a problem. So just avoid this. So what is the solution for this? The solution for this particular problem is to create a copy of the list rather than iterating on the existing list. So that can be done either using list comprehensions or slicing, or use list.copy. So let us look at an example. Here is the solution for that. So we have a list. We can create a new list by doing this. This is using a list slicing. So alternately, we can also do my list temporary is equal to my list dot copy. You do, because we are using another list for iteration and the original list for iteration, which works. We can do this as well, where we are temporarily creating a copy, but it's not the copy that we did. It happens automatically, same thing. So you can see this. So another solution is to use list comprehension, which creates an internal copy, and then we assign that list into the same variable but different list, and hence we have what we wanted, which is to remove all the 3s from the list. Another common mistake is to remove an element which does not exist. It seems it's very trivial, but when we hardcode things, this appears. So let us see what happens when we try to remove an element which does not exist. So element 6 does not exist and gives this. Probably you are hardcoding a username or something like that, and it happens when we hardcode things. So solution for this is to just add a condition which says if 6 is in my list, only then remove it. Another common mistake is to misunderstand slicing. So when we say 1 till 4th, probably the programmer means from 1 and this element, which is 4 elements, from 1 2 3 and 4. And when we try to print it, we can see that it prints from 2 3 4 2 3 4. So we must understand that the index starts from 0 and ends with n-1, because we are starting from 0. So ideally, if you want to get item 1 2 3 and 4, you must ideally begin like this. Let's take a look at another mistake while sorting a list. So there are two functions which does the sorting, which is used for sorting in a list. One is sort and another is sorted. So let us look at what sort does and try to print what sorted list prints. You can see that it doesn't return anything, which is none. The reason is very simple, because this particular function sorts in place. So, but let us take a look at sorted. See now, there is a function which is a global function. You can use it for various other data types. So we send my list into sorted and it returns a sorted list, which is a sorted list. You can also see that my list is not altered. So that is the main difference between the sort and sorted. Now let us take a look at another example which is related to copying the list. Say for example we have a list 1 which consists of two lists inside lists, which is a nested list. So let us see what happens when we try to modify one of the elements in list 2, which we now assume that it's a new list, and print list 1. So you can see that at first position, which was 1 here, which got modified to 10. So the reason that is happening is because the addresses of these lists are same. So how do we check that? Is quite simple in Python. We can use id, which sort of prints the addresses. You can see that the addresses or the id of these objects are the same. So how do we get out of this problem? Is quite simply we can use something called as deep copy. You can see that this is not still changed. The reason is that this particular copy function, inbuilt function for list, is as it shows, it returns a shallow copy of the list. So another thing that you need to keep in mind while we think that it is a deep copy or copy of the list, but it's not. This we import something called as copy, and now you can see that list 1 is unaltered and list 2 is a new list. You can see that the IDs also have changed here. So that's about shallow copy and deep copy, which we need to keep in mind. Let us take a look at another interesting example. This is about modifying a list wherein we append the existing list. So let us look at this particular example. So we have list 1 which consists of 1, 2, 3, list 2 which consists of 4, 5, 6, and I'm trying to append list 2 to list 1. Let's see the output. You can see that there is another list which is embedded inside the original list. So that is what append does. The reason that people make this mistake is we are used to append one element at a time while learning. For example, I can add 7 append and look at the list, and this habit sort of percolates down to other data types as well, and hence we make this sort of mistakes. So how do we solve this problem is, so when we are dealing with a list with another list, we must choose extend instead of append. So this is the right way to append a list or concatenate two lists. Let us look at another example, which is a common mistake where we make one of the arguments in the function, which are default arguments, as mutable objects. For example, mutable means which can be changed during the course of the function. For example, so add to list is a function which takes an item and a list object, and then we try to append that particular item to the list that we sent as a second argument. So first one is okay. The first time we call the function is fine, but second time when we call the function, the expected outcome is just 2, not 1 2. So why 1 2 happens is that that happens because it creates some sort of static object like in C++ or Java. So it is shared among all the functions. So when you call the functions for the second time, it appends to the list which we have already created. So in order to avoid this problem, we must make sure that we never send any mutable objects as default arguments, not the arguments of course, default arguments, and you can make them as none, which is and then you can create a new list here. My list is equal to, and then we can do as we please. So this is the outcome that we're expecting. So this is how we fix that problem. Thank you for watching. I hope these examples were useful. I'll come up with more examples in this series. See you till then. Please like, subscribe my channel and comment what you think about this.